So you can hear me? Okay. So now we begin. Only a few people left, but still we have some familiar faces here. I'm very happy to see all of you here. I know you spend your money to pay for the entrance tickets, then I will try my best to deliver my speech. Today, what is the main content of my speech? That is, the water and the fire, they can be integrated. That is, we can run the Windows container and Linux container on Windows. So simultaneously, they can run on a 2019. About myself, I'm Peng, the MVP of Microsoft, the only one mixed cloud MVP for Microsoft. I am now working in DaoCloud, so based in Shanghai, mainly focusing on the mixed cloud digital platform and container service. So for me, I will focus on how we can use private cloud and public cloud to develop mixed cloud. So first of all, container and combining knowledge with actions. I know there are foreigners. You might want to take some time to understand it. Wang Yangming, you might know these people. Well, he is a philosopher in Ming Dynasty, highly prioritized by President Xi, and he mentioned about combining knowledge with actions and how we apply this idea in container. If we read the book of 传习录 in the second volume of that book, there is a message to Wang Yangming, and he said, if you search for reasons out of your heart, then the knowledge and the actions can be combined. So in other words, if you search for real ideas and real philosophies in your heart, then you can combine knowledge with your actions. Then how can this be applied for container? In 2013, a very famous slogan is that the code and the running environment are in the container. Then no matter you are writing codes or you are operating the containers, what you can see will be totally the same. So that is the knowledge combining with actions. So with that, we see details. Windows itself currently has a saying of container. Windows also have container, but it's not called dog, because it's only being called by dog itself. So the container of Windows, yesterday, Windows Server 2019 was launched. But you see the image base address was changed. It's not .hard. It's mcr.microsoft.com. And the tag is put as 2019. 1809. Currently, there are 3 images, that is server core, nano server, and a Windows server. In my machine, all the images are being downloaded, so I can show you here. I only need to run dog image. It's very interesting. So these 3, that is Windows Server 2019. I downloaded to the Windows 10. And you might be familiar with the bottom 2 image, that is the container of Linux. And as image, they are running on my Windows 10 simultaneously. So we already see the possibility, and I will do the demo for you. That is to run these 2 types of containers on Windows 10. The Windows container is a little bit large. For server core, there's around 4 gigabytes in size. If you're using nanoserver, it will be around 300 megabytes. But of course, cannot compare them to Linux container. Linux containers are very small. If you want a full function container, then such container will around 10 gigabytes. We heard that the container of Microsoft can further reduce its size. And then for Windows container, how we achieve information isolation. If you watched a video of a book written by Zhang Lei, that is a deep understanding of Kubernetes, he introduced that my dog, how I achieve that in the Linux dog. So it's a isolation being done, like PID, ICPC, user, and also file system. For Windows, similarly, it has the technology for information isolation. It's very similar to the IPC isolation of Linux. Each naming space will add silos as the prefix. So silos/504 as the prefix. While the numbers might be random. On the right hand side, if I open this Explorer, you can search for the container and a handle being allocated are all added with a prefix of /silos/504 or other numbers. So no matter how many signals are used in the containers or if with any other differences, well, as long as you add these prefix, then different containers will be able to isolate information. Then they will be able to communicate using traditional Windows way of communication. They will be forced to use doc because they cannot see each other. Then, for accounts in Windows, what are the differences comparing with Linux? In Windows container, if I'm running of who am I, then it will tell you you are the container administrator. Then these progress is the administrator, but it doesn't have other access rights, or it is not recognized. And if you click on it, the user's ID is unknown. Then on the host, such user won't have any right as administrator. Then it's quite similar to the user account isolation on Linux. And then container resources isolation. It's very similar to C group. For example, like the progress of Linux, it can be set as isolation using a CPU, but Windows we're using job objects to manage the progress and the progress group to isolate the resources. A simple example here is that I set this command to set the size of the container will not exceed 512 megabytes. Then we can use the Docker run, and that's -m512 megabytes, and you can see there is a container progress. It will not exceed 512 megabytes. You can see the screenshot here. We use .ps to find the ID of the container. And similarly, using the Explorer to open this window, switch it to this page. You can see the job limits here. Written the job memory limits as around 512 megabytes. So the command of doc will directly be translated to the C group of Windows, so that we can limit its size of the container.
That's how it works. Let's look at Windows and Linux comparison. I will start two processes and two containers simultaneously. One is Windows and one is Linux. In order to separate them clearly, I will use two windows here in parallel. The red one will be the Linux container, and the black one will be the Windows container. Let's run the Docker image and then .run. The ID is the same here. Let's suppose we run this. (1809). This is the latest version of container, and it's a serve code. And on the right, I will do the same thing.
也去 好，这边我同样运行。
On the right, I will run the same command.
但是呢，我会在里面呢直接去跑这个。
But I will run the bundle system directly.
一万一万。好，你看，二进进。
So it's working. So the left is Windows and right is Linux. And on the Windows,
我们比如说想要看看 Windows 的这么一个容器。
we want to see how process is going and how servers are going. So we can use this command. Do you know that? Do you know task list slash SCVC?
它跑的里面跑的那个进程，
And
后台的进程。
this is a back-end service, and it's still very big. And we will do the same thing on Linux.
这个 Linux 的容器
See how it's doing on Linux.
它只有多少？
And it's just one process. Just the bash itself. So this is a comparison between Windows and Linux, a very big comparison. I started my career in 2004, and I'm now MVB in Microsoft. And I started in Microsoft's Windows. I feel glad seeing this progress, but I hope they can improve further. And this has a historic accumulation. Windows, the graphic interface is included in the container, like the Windows arcade. And as a result, the kernel is huge. So in containerization, the Microsoft starts very early, and it just released its container in 2016. But around a decade ago, the Microsoft has approved a job grade project, start to promote its containerization, and until the release of Docker on market, Docker became very popular. And then Microsoft joined together with Docker, and Microsoft has its own container, and they mastered the API. And Microsoft Server 2016, the Docker's Enterprise is installed. If you want to run Microsoft Windows container, then you will be supported by Microsoft. And in the future, the Linux containers capabilities will also benefit from Windows. This is a win-win game. Let's proceed. So how do we see the combination of Windows and Linux? And here's what I want to say. Can we run Linux containers on Windows? Is a question. The answer is yes. Why? Why can't we run Linux containers on Windows? Because whether it's Docker or container or other same level virtualization technology, the core is they share the kernel. And Linux containers, that's why Linux containers can't run on Windows. It's the same way around. For Windows containers, they can't run on Linux. And if we have a low version OS, we can't run a high version Linux container, because the high version Linux container have requirements for the kernel. It's the same thing. The the low version OS doesn't have the required kernels. And in these 2 days, we have learned a lot from our Kubernetes contributors. And in Kubernetes, there is a wealth of tools, and these can also be used to combine them. And if you have attended the meeting on 13th, then you must have known the Anya's Multec is released in China for its Kubernetes service, its private cloud service is about to be released. And such an orchestration tool like Iron's container service can all support our Windows capabilities, just like what's shown here. You can see right now what I'm running is Kubernetes node, and it's a Windows version. So when will Kubernetes support Windows officially? Until the version 1.13. It's not a long time to go. And when for our DaoCloud product, it's the first or the only system that can run on cloud that is private and also public to support the Windows. And here's another issue. Well, to say that Linux containers can run on Windows, it also makes sense. The Windows 10 and also Windows Server 2016 all support the Linux and also Windows containers. And their capabilities is to use Hyper-V containers and also Docker's Linux Kit technologies. So what it's using is Hyper-V containers and Docker Linux Kit technologies. Linux Kit is a proprietary technology of Docker. It's streamlined and it's super easy. And as a result, on Windows we can run Linux containers. On the plus side, we can also achieve the hypervisor level isolation. As I said, for the common Windows or Linux containers, its isolation is just a kernel level. So if there's a problem with a kernel, like a loophole or a bug, then everything, including the container, will be damaged. In addition, if we can have hypervisor isolation, we add a share for every container. It's just a small VM called a utility. Sorry for the typo here. I need to change. I'll make it right. So it's utility VM. And the utility VM its speed is much quicker than the common VMs, and it's a Hyper-V container or VM. And you will not see it. The VM is hidden somewhere, and the life cycle is the same as the container. as long as there is a container, then there is this VM. If there's no container, then there will be no VM. So I just run the two tests. Let's look at the Hyper-V. Can you see the utility VM here? No. If you doubt it, then I will upgrade it for you. Then still there is no utility VM. So it's a very, very small virtual machine. And when we run .run, it will automatically run on the machine with and the Linux is a Linux. The kernel is Linux Kit, and the Linux Kit can help us to run the conventional Linux containers automatically. So the speed, as you can see on my Windows, is very decent. Although compared with the Linux container, it's a bit slower. Still, it's very good. By doing this, we can run both Windows and Linux containers on my Windows. So what are the advantages? What do you think? I think there are 3 points. The first is, as a technology lover, and it's a nice thing to run Linux and Windows containers on the same platform. It's a very interesting thing to do. And second, it can save the resources. Well, previously, we divided between the Linux and the container, and they were independent. Linux containers run on Linux, and Windows containers run on Windows nodes. That's a waste of resources. But if we can change it to the unified Windows code, then we can schedule both Windows and Linux containers simultaneously on the same machine, and that will save lots of resources. And third, what I need to stress here is, you know that DOC's enterprise version is very stable, and it's for the enterprise application, but you need to pay for this. But if you enterprise have already purchased the Windows, then you can just use this built-in function. And because the DOC enterprise was built in the Windows already, for your companies, your base will be the Docker's enterprise level. So whether you use Windows or Linux, it's both okay. And you can also get the official support from Microsoft, just like the Microsoft Iron. Above, we can also run Linux virtual machines. And domestically, 70% of the irons are open source OS.
So Microsoft wanted to achieve the purpose in this way. Then, what is the principle of Linux container? It is a native Linux container. At the bottom, we have Linux kernel. We use D to receive comment like documentation download, and it will translate our command so that run C can understand, and then transfer to Linux application at the top level to run that container. By isolation of secret and container, the process can be protected, so it's a non-purpose. But it has the namespace isolation and secret isolation. If I put this to Windows, and it will be like this. At the bottom, that is a hypervisor. The green part is still the same. The green container D. Here is the port going through HCS. The host computing service inside a window to transfer my request to the GCS, the guest computing system, and also using runc to run that container. Due to these orange components, they are in a high speed, so they have a very good performance. So it's safer than dock. There is a kata of Intel, just similar. I talked with Zhang before, and he says it's very similar to kata. Also running a very small virtual machine inside it. So skip the random talk, we just run the demo. So exit the Windows container, it's very quick. I will run the command. Linux container will go through the HCS to deliver the command, and we can use HCS die list to see all the information related to a hypervisor. I can see in this machine there is a Hyper-V Linux container, and the ID is here. And then we use Hyper-V. We cannot see the small virtual machine inside it, but you can see it here and run the command here. So I copy the container ID to run a console or utility VM. Follow this ID and then at the bottom click enter. You will enter this utility of the container or utility VM, and I can run a command to make sure that like unit-a. So it's running an OS here, and then it's kicked, and the version is 4.14. And I can run the PS. In the whole utility, you can see the host has many progresses. If you used Microsoft, then you might be familiar with that. And I can show something that you must be familiar with. So this is inside it's embedded in the Linux, and follow up. There is something I mentioned before. HCS to the GCS. So you can see here, it's connected. And also, do you know what it is? So this is the progress of the container. Before we set that for container, on my host, it's always a standard progress, but there is a 6 layer of isolation and also an isolation of C group. Now we know that the PID is 349. What is the PID inside the container? That is 1, because it's isolated. And we can see the namespace isolation. If you watched the video of Zhang Lei, you must be familiar with that. IS-IL. So in this catalog, just now it was 349. So there's a catalog for isolation. So comparing with the standard Linux container, you can see it's totally the same. So the 6 namespace isolation. And follow up. A more interesting thing can be seen here. We can run a mount. And it's more interesting what you can see from here. So at top level, there are 4 EST4 partition. And it's read only, and it will be mounted to the memory. So the 4 partition will be the base image for the container. So they will be put into 4 layers. So at the bottom layer, there are 4 layers. And will be mounted to the utility VM. And on the top, there is a writable layer at the very top layer. It's readable and writable. But when we kill the container, the layer will be dropped. It's not exactly the same as dock. It can also be seen as a dock itself. In this utility VM, there's no dock. It's only using the dock on the Windows, and it's automatically generated. And now we open this Process Explorer. We find these utility VM's progress. So it's a normal Hyper-V WP workload progress. And we can also see here the mounted 4 layers and its image. So it's already mounted. And on the top level, the sandbox will be loaded, as you can see here, as the SADA, a virtual SCSS. And you can see it's going through my Hyper-V store VSP to load the VHD function. To load the VHD without committer, any revision will be dumped. So you might need to set those data on the IO files or in the local host. And we can also see in the Explorer, the Hyper-V work, we can also see a message when the application or when the container is started. There will be 4 messages, 4 logs. If we open it, it will tell you that this layer was loaded in my memory, and it will tell you the specific information. Another information will also tell you the Sasankic and load another sandbox, readable, writable, So this is the content I wanted to share with you today. Have a deep understanding of Linux container on Windows. If you want to have a try, it's very simple. You can go on the dock and download that dock for Windows, the latest version of dock for Windows. And you can directly choose this and click on it, and you'll all understand that. And set a mirror here. Otherwise, you need to download the container's image. It will be very large. But I will also recommend you to use the DaoCloud, the first in China. After you finish setting them, switch them to this Windows container. If it is same for Windows Server 2019, and everything will be quickly done. A quick question for you. If you run Linux container on Windows, how many IPv containers can be run in your pod? Can anyone answer this question? In Kubernetes, a pod should run multiple things. If it is the IPv container, how many things can be run inside? For me, I don't think multiple things can be run inside. One pod will share other namespace. They should be bridged together. But for Hyper-V container, it was isolated by hypervisor. Then it won't be able to be connected unless in the Hyper-V container, in a small virtual machine, you can run multiple containers. Kata container, if it can support Kubernetes, it will use the same principle. Thank you for your listening. If you have any questions, feel free to ask me. The audience is not using the microphone. Interpreters cannot hear. For dynamic framework, I forget about the version. If you want to support it, maybe you can use the microphone. We have 4.0 version of that. Well, for your question, if you're going to run traditional, so a few seconds, a few minutes. You're going to run such a traditional framework. Remember to use them. One is server code, and the other is Windows. Instead of Nano server, you can only support this one. If you use Dock server, you can run both. Then you will have a large image for that. So around 10 gigabytes for that image. And we might remove some function for the image. After testing, even though it has function for desktop, you cannot use the terminal visit to access those interfaces. Inside the Windows container, don't put any images because you cannot see them. Even though it's a completed version, but it cannot be run. In the beta 3, it can support that, but the future version does not support that. If you still want to use it, of course you can. there are many other
远程终端的这个功能啊，
remote terminal can be connected to that,
由于 VNC 啊，这个
like a VMC.
但是里面是不是导致这个4.5？这个
But I'm not sure whether it is the framework 4.5.
是最新版本的这个
If it is the latest version, it can support that.
只能 support
If it can only support 4.5, then it won't be able. You need to change the codes.
我用 Kubernetes 的时候，就是用 Windows 容器的话，那我网络怎么去处理呢
？Windows 的容器的这个网，这是个非常好的问题啊。
So when I use Windows Kubernetes, how do I deal with the network? This is a very good question. Now Windows network can support lots of things, and we have official documents. And if you search online, then you will find the Windows container. And you just put in Windows container, and the first result coming up will be on the Microsoft website. If you use Kubernetes, then if you at 1.13 version, then it should contain the aliens and also the route information. So I think you still need to wait for a bit. Thank you. Do you have any further questions? If not, then that will be the end of my presentation. Thank you so much for coming, and thank you so much for coming to the KubeCon.